This is the answer for example 1. Although we say that angles must always be written in one decimal place, but because this question specifically asks for 4 significant figure, so we just follow what the question asks. Okay, you can pause the video and copy down if you need to. Whoops, I forgot to put a bracket here. Alright, so let's look at example 2. Recall in worksheet 1, we look at these two triangles, PQR and ABC. So we need to find the angle PQ and angle A. How do we do that? Now we are given the length of all three sides, which means that it is up to your choice. Okay, when you are asked to find angle, you should always recall the trigo ratio. Okay, this three, and then you need to decide, make a decision here, okay, on which one should you use. But since you're given everything here, you can basically choose anything you want and you will still get the correct answer. Okay, you can use Tuaka, so as long as you use the correct side lah. Okay, now let's look at the first one. They want angle angle P first. So let's try to find angle P. So where's P? So if I want to find the angle P, then I would use pencil, okay, because you might have to change it later. Angle P here, I will use this as my angle P as my reference angle. So I have O, I have A, I have H. I basically have everything. So if I want to find angle P, I will okay, my choice, let's see, I will use sine, okay, 3/5. So I will do sine angle RPQ, it will be equal to 3/5. So the angle RPQ would therefore be sine inverse of 3/5. You key this in the calculator, you get that this is 36.9 degree, 1 decimal place. How come it looks sengit? Is it slanted? Okay, I don't want to redo this video already. Okay, angle A. Let's take a look. It is the other triangle. I'm gonna erase all the marking. So angle A over here, I will have O, A, and H. So let's do the same thing. Let's do the same thing. Let's be consistent. We use sine over here. So angle A will be sine angle BAC will be equals to 6/10 as given by the question. Then I get angle BAC will be equal to sine inverse 6/10. You want to simplify, you can do that. And I get my answer is 36.9 degree, 1 decimal place as well. Hey, how come it's the same angle? Because it is actually an enlargement by a scale factor of 2, right? You take all the sides times 2 times 2 times 2, just like in the previous example, and then you get the same ratio. Remember in worksheet 1, we mentioned that they are similar triangles. Okay, if let's say the angles are fixed and then I just expand it, okay? Trigo ratio will be the same if they are similar triangles. Second part, R and B. Angle R. So over here, I will have H, O, and A. Okay, so let's find angle R. I will call this cosine. Let's use the other one. Let's use cosine instead. Cosine PRQ is equals to 3/5. So angle PRQ will be equal to cosine inverse 3/5. And I'll get 36.9 degree, 1 decimal place. Sorry. I'll get 53.1 degree, 1 decimal place. Next, I want to find angle B. Make a guess. What is angle B? It's gonna be the same thing lah. So this will be O, A, and H, right? So let's do the trigo ratio. I use cosine ABC, which is equal to 6/10. Okay. So cosine inverse of 6/10, I'll get 53.1 degree, one decimal place. Okay. Now the conclusion here is that if two right angle triangles are such that the sides are proportional, then the corresponding angle will be equal. They are going to be exactly the same. Okay, so this is a conclusion I'm going to draw. Right, next video I will move on to example 3 and we'll look at the application of trigo ratio. Okay.